Hello, everyone. I'd like to start by thanking everyone for coming. Welcome to Cephalocon, the very first Cephalocon conference ever. Welcome to Beijing. One of the first things I'd like to do is, in addition to thanking all of you for coming, I would like to thank all of our sponsors whose generous support has made this conference possible. Please take time while you're here to visit their booths out in the hallway and find out all that they have to offer. I would also like to thank all of the organizers for this conference whose hard work and dedication has made this possible. Do IT and the hard work of all the volunteers, please come up. Welcome, everyone. Thank you all for coming. I'd like to start, of course, by just talking a little about what Ceph is to me and to the rest of the community. So at the highest level, we describe Ceph as a unified storage system, unified storage software, which means that a single cluster running Ceph software can serve object, block, and file workloads within the same system. So RGW is the object gateway that provides S3 compatible storage services. RBD is a virtual block device with a whole range of features, including cloning and snapshots and so forth. And CephFS is a scalable distributed file system. And all of these different services can be backed by the same Ceph cluster that's based on Rados, which handles all of the reliable distributed storage, elasticity and redundancy and so forth in your system, with both erasure coding and replication services. So this is, at a high level, this is what Ceph does and what you get out of the box. But I want to talk a little bit about what makes Ceph Ceph, what makes it different from other storage systems, and what motivates us as developers and as a community to build Ceph the way that we do. First and foremost, Ceph is free and open source software. And this is important for a number of reasons. First of all, we believe that free software is a better development model. It means that we can have engineers and developers across lots of different organizations across the entire world that are collaborating on a single software project to make it better, to serve more users and to serve them more effectively. Open source also enables the free integration of complementary projects. So Ceph can be integrated with other projects like OpenStack or Kubernetes or Hadoop or anything else that we haven't even thought of without somebody having to come ask us for permission. Because it's open source software, we can build this entire ecosystem of different software components and put them all together. Free software, we believe, is better for the user. Because it's software only, you can deploy it on any hardware that you choose from any vendor. You have the flexibility to deploy it on hardware that fits your use cases and your needs without being confined by what somebody else decided was the best choice. And also that software freedom allows you, prevents you from getting locked into a single vendor. So if you're getting Ceph software or Ceph support or Ceph services from one vendor and you don't like the way that they're helping you, then you can move to somebody else, or you can choose to support the software yourself and not pay anybody. And free software enables this fundamental freedom. And finally, free software is better for the world. My favorite story here is a researcher that I spoke to at a university in Canada who was doing some sort of cancer genetic research. And he was telling me that it wouldn't be possible for them to do the research that they do without Ceph, because they simply didn't have the money to afford a proprietary storage system to serve their storage needs. But because there was a free and open solution, they're able to do some groundbreaking research that's going to save lives. This is one of the things that motivates us as a community to build Ceph the way we do. The second thing that makes Ceph distinctly Ceph is that Ceph is built to be reliable. It's designed from the ground up to have no single points of failure. And it's designed to provide a reliable, durable storage service, even though the cluster is built out of lots of unreliable individual components. And we do this through the use of data replication across nodes or across hosts or racks, and through the use of erasure coding, depending on what your requirements are. Often when you're building systems like this, you're faced with a choice. It's possible to take a shortcut or to cheat and to make the system go a lot faster at the risk of getting an incorrect result. Whenever faced with a decision like this, Ceph always chooses to do the thing that favors consistency and correctness over performance, so that we can build a system and a community and an ecosystem where people can trust the system with their most important data. Now, there are a lot of different ways you can take storage hardware and connect it to your applications. And there are a lot of applications that actually don't need very much reliability. It's possible that in a lot of cases, if a storage device fails and you lose the data on it, it doesn't matter. And that's totally fine, and that's useful for a lot of different environments. But Ceph is not really as interested in those types of use cases. We're focused in the environments and the workloads where it is very important that your data is reliable and durably stored across multiple devices. And that's really where we spend our time. Finally, Ceph is designed to be scalable. Originally, when we were designing the system at the University of Santa Cruz almost 14 years ago, our focus was on building a storage system for a supercomputer where we had an entire data center scale storage system. Over time, the use cases for Ceph has clearly evolved, but one of the key motivations and ideas was that as an organization grows, the requirements for how much storage you need are going to grow with it. And so Ceph is designed from the beginning to be an elastic architecture. So you might deploy a particular cluster. As your storage needs grow, you can simply add more storage. And maybe if your storage needs decrease even, you can remove storage. And the system will seamlessly deal with that change. Even while you're using it, while you have real workloads using the system, you can add and remove storage components. One important part of this is that as Ceph is updated over time, you need to be able to upgrade the software. Again, while the system is being used, while you have data I/O, in order to make the system run the latest version. And we think about scaling Ceph in two different ways. The first way is when we scale out a cluster, when we simply make a cluster bigger by adding more racks of storage, more disks within a data center, and simply making a bigger Ceph cluster. We also think about scaling storage needs across an organization where you have multiple data centers in different geographies in different regions of the world, and making Ceph clusters talk to other Ceph clusters and interoperate and sort of to build a global data pool. And so we consider both of those things as part of the importance of Ceph scalability. So Ceph, the Ceph community generates a major release every 9 months. Each release has a name. We released Luminous about 7 months ago, last August. Mimic is the next release. It's going to come out in about 2 months. And after that, we'll have Nautilus. We maintain these releases in the community for up to 2 years. And we allow upgrades up to 2 versions at a time. So you'll be able to upgrade from the Luminous release that came out last August all the way to Nautilus you could choose, or if you want, you can go to Mimic. So Luminous is the current most recent Ceph release. It came out about 7 months ago. And Luminous brought a whole wealth of important features. It was a very big milestone for the community. Lots of important things. I'm going to call out just 2 of those. Blue Store is a completely new backend for the Ceph OSD that allows the storage nodes to talk directly to the storage, cutting out a number of intermediate layers. That brought a lot of additional performance to Ceph, and also allows us to take better control of the overall storage stack. And one of the other key features for Luminous was the addition of erasure coding support for Rados block device and CephFS workloads, in addition to the object workloads that were already supported, and lots of other things in Ceph. The next release, which is going to come out in about 2 months, is Mimic, named after the amazing Mimic octopus. And I'll talk about just a few of the highlights of Mimic across the different parts of the system. As far as core Rados goes, this is the underlying storage layer that underpins all of Ceph. There are a few key features. PG merging and autoscaling addresses sort of one of the key configuration complexities that users have struggled with over time. There's going to be centralized configuration management through the Mons and experimental quality of service. I encourage you to catch Josh Durgan and Greg Farnham's talk about Rados a little bit later this afternoon to get a much more detail about the roadmap and what's going on in the Rados world. On the Rados Gateway object side, this is the S3 gateway. There's a new feature coming that will allow us to replicate an object storage to a public cloud service like S3 or other S3-like cloud storage services. There's also a lot of ongoing work in Rados Gateway to improve performance and scalability in the gateway itself. Please catch Matt Benjamin and Urit Wasserman's talk about Rados Gateway also later today to find out more about object storage and where it's going. On the RBD block side, there are also a number of features coming, things like image groups, deep copy, and live migration that will allow you to move a device between clusters or parts of the cluster, pools of the cluster, while it's actually being used. Jason Dillerman is the lead developer for RBD, and he'll be talking about that later this afternoon. And also on the CephFS side, for the POSIX distributed file system, a lot of work has gone into stabilizing the snapshot feature and adding quota support on the quota and a number of other things. Please catch Patrick Donnelly's talk later today as well to find out more about that. So lots of little features, lots of things coming in Mimic. that I could talk about. But what I really want to do today is focus on sort of the bigger picture, where it is that Ceph is going in the future, and what the sort of the key ideas and key problems and challenges are that motivate us, and where we're focusing and where we think Ceph is going. So as I thought about this, as we sort of look at the road ahead, the cloudy road ahead, I've identified 4 key challenges and opportunities that I want to talk about. Performance, new platforms, ease of use, and scaling. So performance is perhaps one of the most important. So with Luminous, we added the Blue Store backend that I mentioned a moment ago that allows the Ceph OSDs to take direct control of the hardware. This is a major step forward for Ceph. It allowed us to eliminate a major source of performance inefficiency and drastically improved Ceph performance under many workloads and across many hardware types of hardware. But as we sort of step back and look at the larger landscape of where the where the storage industry is going, we see a number of important trends that we need to pay attention to. The first is that hard disks are increasingly being relegated to streaming and archival workloads. So when you have lots and lots of data that's relatively cold, it's not being read or accessed very often, those are the only cases where we're going to be really using a hard drive going forward. Everywhere else, people are going to be deploying flash because it's a much better price-performance equation. People are going to, in fact, if you look forward maybe 1 or 2 years, I would expect that the majority of Ceph clusters are going to be only flash. We also keep hearing that persistent memory technologies like 3D XPoint are coming soon, and it continues to be the case that they should be here soon. And those are also going to drastically upend the types of hardware that people are going to be using in storage systems. And what we find when we build Ceph clusters out of these high-performance devices is that the performance of the system is no longer limited by the storage devices, but is actually limited by the CPU that's sitting between the storage and your client applications. With every Ceph release, we spend a lot of effort trying to optimize and improve performance, and we're making continual improvements. But what we found is that we need to make a fundamental change in the way that the OSD code is structured and built in order to capture the performance of this next generation of storage. And so currently, there's a significant effort underway to rewrite much of that OSD path using technologies and tools like C-Star, DPTK, and SPDK in order to fully capture the benefits that we get from NVMe flash and some of the newer storage devices that are coming. So for more information about this, again, I encourage you to check out Josh Durgan and Greg Farnham's talk later today. They'll talk about this a bit more. The second key trend and challenge I see is new emerging platforms in the overall computing infrastructure space. And to get an idea of why this is important, I want to talk just a little bit about OpenStack and Ceph. So OpenStack and Ceph are 2 open source projects that really grew up together. And what we found with Ceph in particular is that one of the main ways that Ceph reached a wide audience and became widely deployed and adopted was in conjunction with an OpenStack cloud. So when people are deploying a scale-out open source cloud infrastructure, it turns out that they also need a scale-out open source storage infrastructure to go with it. And so it was a natural fit. And this was a great benefit for the Ceph community and a great benefit for the OpenStack community. And because we spent effort early on making these 2 technologies work very well together, both communities benefited greatly. As we look forward, we find that there are new orchestration platforms that are also becoming very important and are getting a lot of traction. In particular, this is the use of container orchestration tools and containers in general to deliver software. So as we sort of look at today and even in the future, containers are the new software packages. Kubernetes is emerging as the container orchestration platform of choice. And again, just as with OpenStack, it turns out that when you build a scale-out application orchestration platform, you also need a scale-out storage platform to go with it. And so there's a tremendous benefit for Kubernetes users for having a scale-out software-defined storage system like Ceph to go with it. But this relationship goes both ways too. Container orchestration is also valuable for storage clusters and storage deployments, particularly in the case of hyperconverged infrastructure. So when you're deploying lots of servers that have both computing applications running on it and the storage within the same host, using these container orchestration frameworks gives you the tools that you need to isolate the performance and the resources between those 2 parts, components, and roles of the system in order to make it all work very well together. I'd like to take a moment to call out a new project called Rook, which is a Ceph operator built for Kubernetes that is a tool that allows you to manage and deploy Ceph within a Kubernetes cluster in a very easy and natural way for Kubernetes users. And I encourage you to catch Bassam Tabara, one of the Rook creators, his talk tomorrow, where he'll talk more about Rook and what the future holds there. The other side of this platform equation is also, we as a community need to pay attention to what the workloads are, where we see new workloads on Ceph clusters and where we see people going. And just a few examples of where we've seen a lot of growth in this area. One is with public cloud file as a service deployments using Cephfs, often with OpenStack Manila, where you have a public cloud service and you want to provide file service to all the virtual machines. We see a lot of growth in the high-performance computing space with Cephfs. One of the interesting new use cases we see is the so-called data lake, where you have a huge object storage cluster with lots of archival data, but you also want to run all of your analytics with Hadoop or Spark that analyzes that data and processes it in place without having to copy it into and out of a different Hadoop-type cluster. So we see a lot of growth there as well. Similarly, we see a lot of interest in using Ceph as a storage backend for data sets that are used for artificial intelligence and machine learning, usually with Spark. We see a lot of use with imagery archives, for example, satellite and medical imagery, and also a lot of growth in the scientific computing space. If you look at the schedule for Cephalocon, you're going to find talks that cover pretty much all of these different topics. Not to mention, not including the keynote tomorrow morning from Dan at CERN, who's going to talk about how Ceph is being used in CERN's infrastructure as part of the data processing pipeline for data coming off of the Large Hadron Collider. Sort of the third key challenge and trend we see with Ceph is the issue of ease of use. So when we first conceived of Ceph, one of the sort of the guiding tenets that we had was that in order for Ceph to scale, in order to build very large Ceph clusters, the system had to be self-managing. It had to automatically deal with all the day-to-day issues with failures and recovery and all the knobs and whistles and so on. And this is something that we've repeated to ourselves for years and years and years. Despite this, however, as Ceph sort of grew up, it gained a reputation for being a very hard system to deploy. There were too many knobs, there were lots of different, it was very complicated to deploy, and it was just difficult to use. And for a certain audience, that was okay. So for the Linux, for the cloud operators that are already used to deploying complicated distributed systems like OpenStack, deploying Ceph next to it was fine. They understood how to do it, how to manage all those different machines, and how to deploy the software, and that was great. And that's why Ceph was so successful in the OpenStack space. But in order for Ceph to be successful in other environments, traditional IT environments where storage administrators are used to having a drop-in appliance with a point-and-click GUI, Ceph hasn't been as successful simply because it's too hard to use. And I fault myself for taking too long to realize the importance of this issue. It was only about a year and a half ago that I realized that this is a big problem with the overall growth of the Ceph community and the evolution of the project. With the Luminous release that came out about 7 months ago, a huge amount of effort went into fixing a whole long laundry list of issues with Ceph just to try to clean it up and make it much simpler to use. Everything from health reporting to the way that logs are presented to a prototype dashboard to the way that you deploy and replace disks, trying to reduce the number of steps to perform common tasks and to make the system much simpler. And that work continues. So in the Mimic release that's coming up, we're addressing the pgnum issue. This is one of the key knobs, one of the key decisions that you have to make when deploying Ceph clusters, how many shards to deploy in your pools. And it's one of the hardest things for users to understand and to make a good decision about. And so one of the things we're working on in Mimic is making the system, first of all, being able to adjust pgnum both up and down, and then having it have the ability to automatically tune that value so that for most users, they won't have to think about or worry about this issue at all. One of the other key things that we're building is a centralized configuration management so that it's much easier to control a Ceph cluster. Even though it's distributed across lots of nodes, Ceph will manage its own configuration and the behavior across all of those systems. But I think the biggest thing that we've addressed, that we're working on to improve the overall usability of Ceph is building a new web-based UI, a graphical user interface dashboard. Mimic will bring a refreshed, rebooted dashboard UI based on SUSE's OpenAttic project that the team has graciously put in a huge amount of effort to merge that work. Previously, it was an external management project. They're moving it into the core Ceph code base and integrating it tightly with Ceph Manager so that Going forward, for Mimic and beyond, when you deploy a Ceph cluster, it'll be a simple switch to turn on a full-fledged, fully featured, robust management GUI to manage your Ceph cluster. This is a huge step forward for the community. And it's great because this project is being moved into the core Ceph project, all of the different organizations that are working to develop Ceph and improve it are all going to be collaborating on the same set of tools and making all these benefits and improvements for the entire ecosystem. The dashboard is going to be used both for managing Ceph clusters, for performing basic operations like adding nodes, replacing disks, creating pools, deleting images, all those sorts of day-to-day activities. And it'll also be used for monitoring, so you can find out where your performance bottlenecks are, who's using what storage resources, and so on. So we're very excited about this. I encourage you to catch Len Scrimmer's talk about the Ceph dashboard in order to learn more about this project later in the conference. And the final sort of key theme that I want to talk about is scale. So again, this is one of the defining characteristics of Ceph, is that we want to make the system be able to grow with users and organizations' requirements, so we make very big storage clusters. And one of the key challenges we have is that even though Ceph was designed from the ground up to eliminate bottlenecks and to be able to scale out and be very big, it turns out that the software developers who are writing software don't actually have access to an entire data centers full of storage servers and disks. So it's very hard for those developers to test. Now, one of the great collaborations we've had is with the folks at CERN, and several times with the past couple of years, we've been able to deploy very large storage clusters for a couple weeks at a time to test new releases of Ceph and identify where the current software bottlenecks are and what improvements we need to make. And each time we've done that, we've made significant improvements. I think Dan is going to talk about this probably a little bit more when he presents about the activities at CERN. But even with this testing, one of the key challenges is that when we do these big tests, we're always generating a synthetic workload. We'll build up a test cluster, and we'll try to throw as much I/O at it as possible and find out what breaks. But that synthetic workload, that fake workload, is never exactly what users are going to do. And so we're never really sure if we're simulating the right kinds of activity for the cluster. And so one of the key things that I'm excited about with this conference is meeting with a lot of you and a lot of the organizations that are deploying large Ceph clusters and find out what are the biggest clusters that you've built, what are the problems that you've hit, what things have worked well, what things haven't, so that we can have a better collaboration and find out what we need to fix and improve in future versions so that Ceph clusters can be bigger and bigger. And again, as I mentioned, we think about scaling not just in terms of making bigger Ceph clusters, but also in terms of making Ceph clusters, multiple Ceph clusters, federate and talk to each other across data centers. Because let's face it, we live in a multi-cloud and hybrid cloud world. IT organizations consist of on-premise deployments, data centers, the use of the public cloud, sometimes managed clouds, and multiple public clouds. And having that sort of multi-regional redundancy and disaster recovery is increasingly important for most organizations. And it's these tools like Kubernetes and OpenStack that are really enabling this flexibility, where these tools are making it much easier to take applications and deploy them on multiple clouds without having to completely rewrite and retool and so on. But the storage component is sort of the last piece that's harder to, that has taken longer to sort of catch up with the ability to deploy these applications across clouds. And so there are a number of things that we're doing in Ceph to try to enable these types of workloads. So on the RGW object side, today we already have multi-Ceph cluster federation and replication. It's been there for quite some time. Looking forward, we're looking at sort of expanding the capabilities here so that we can replicate data not only between Ceph clusters, but also to public cloud infrastructure, like S3 or other public clouds, and also the other way around, so that you can have data sets that span public clouds and private clouds, and eventually you'll be able to move your applications between those clouds and seamlessly have the data accessible from both. On the RBD block side, it's a similar situation where today we have a multi-cluster asynchronous replication capability where you can have block devices that are replicated to another Ceph cluster. And if you have a disaster and a failure, you'll have a point-in-time consistent copy of all those block devices in a separate location. And you can fail over and fail back. Looking forward, we're looking at better tools and better integrations with tools like Kubernetes and things built on top of Kubernetes that are migrating applications around in order to move that information, that state between clusters in order to enable a truly portable infrastructure so that you can have applications that are moving while they're being used between clouds and have all the data and all the state follow it around. And finally, on the Cephfs file system, a similar situation where we want to figure out how you can have a unified file system namespace that's accessible in multiple locations and where changes are updated and propagated across multiple sites. So this is sort of the direction that we're thinking and where we're going as we think about the future. So there are a lot of ways that you can get involved in the Ceph project and Ceph. One of the first things you can do is come to Cephalocon, so I'm very glad to see all of you here. We have a number of Ceph Day events that we do put on around the world every couple months, in Asia, in the Americas, in Europe, and the Middle East, and Africa. So those are one way that you can learn more about Ceph. There are regular meetups. We try to keep track of those on the Ceph website. I'm not sure how many of the Chinese events are organized there, but we'd certainly like to have them. We have regular Ceph tech talks. Once a month, there's an online video streamed technical discussion about some aspect of Ceph that you can stream and you can watch at your leisure. For developers and users, there's mailing lists in IRC where you can join the list, you can ask questions and interact with other Ceph users around the world. All the Ceph source code, of course, is all open source. It's all on GitHub, so you can go look there. You can see what development activity is happening. And we also have an event called the Ceph Developer Monthly, where every month we have a video conference discussion online where all the Ceph developers get together and just talk about whatever the issues are that we're currently working on, what the current design challenges are for some new feature, or whatever it is that's currently going on. And we do this once a month, and we alternate between times that are friendly for the Asia-Pacific region and times that are friendly for Europe. So I encourage anybody who is involved in Ceph development to check all these resources out. And that's it. I'd like to thank everyone again for coming. Welcome to Cephalocon. I hope you enjoy the conference. Thank you.